A rectangular coil of area 6 cm square having 3500 turns is kept in a uniform magnetic field of 0.4 Tesla. Initially, the plane of the coil is perpendicular to the field and is then rotated through an angle of 180 degree. If the resistance of the coil is 35 ohms, find the amount of charge flowing through the coil. Let us start. Here you have the plane of the coil. The area is given in the problem as 6 cm square and it has how many turns? It is given 3500 turns. It is kept perpendicular to a magnetic field of strength 0.4 Tesla. The area is perpendicular to the magnetic field. The area vector is parallel to the magnetic field vector. So, it now rotates through an angle of 180 degree. Let us solve the problem. I, the current given by dq by dt, and I by Ohm's law, epsilon by R. Now let us go to the solution. The amount of charge flowing through the coil is given by the formula dq equals I dt, right? This is from the first formula we have taken. Let us substitute I as epsilon by R. Good. We have substituted here epsilon by R. This epsilon is the EMF. This EMF is induced due to the rate of change of magnetic flux. So dq equals, instead of epsilon, we write d phi b by dt by R into dt. Here the dt term, let us now cancel these two parts and let us go further. dq equals d phi b by R, the resistance of the coil. What is the flux, magnetic flux? It is given by the formula NBA cos theta. dq equals dNBA cos theta by R. In this particular, the N is constant, the B is constant, A is constant. The change happens only in the theta term, right? So what is the change happens in the theta, the angle term? It goes from 0 to 180 degree. So let us write that in the next step. NBA, the difference in cos theta term divided by R. So the difference in cos theta term is, the final part is cos 180 minus the initial part cos 0 divided by R. Cos 180 degree, how much you know? Cos 180, you know how much cos 180? It gives you minus 1, and cos 1 is 1, cos 0 is 1, minus 1, and here you have 1 minus, so minus of minus 1, it becomes minus 2 here. So dq equals 3500, that is the number of turns, and let us change the area. Let us change the area from 6 centimeter square to SI unit 6 into 10 power minus 4 meter. What is this? This is the magnetic induction 0.4 Tesla, and we have substituted the change in cos theta divided by the resistance. After simplifying this simple calculation, we get dq equals 480 into 10 power minus 4 coulomb. Simply dq equals 48 into 10 power minus 3 coulomb, 48 millicoulomb. Thank you, children.